Hello everyone, welcome back to today's chemistry class. So today we'll be looking at Introduction to Applied Chemistry. Before we continue with the class, I want you to consider this question. In the pharmaceutical industry, drugs are designed using applied chemistry. How do chemists ensure that a new drug is both effective and safe? What could be the risks if a chemical reaction in the drug synthesis process is not properly controlled? Okay, you might want to pause this video and quickly meditate on this. I want to believe you'll be having a different opinion if you are watching this video as a group or as an individual. But it is best for you to pen down your response and think about how it applies to topic we want to look at today, which is applied chemistry. Our end in mind for today's lesson, you will be able to explain the practical applications of chemistry in everyday life, including the development of new materials, pharmaceuticals, and sustainable energy solutions, and analyze how chemical principles are used in industry to solve real-world problems. So sit back and enjoy the class. So what is applied chemistry? Now basically, if you go to the university or you gain admission to the university rather, basically students, they can study what we call pure chemistry. They can also study applied chemistry. So you can choose that you want to study pure or applied chemistry. So actually there is a difference between pure chemistry and applied chemistry. Basically, when we are talking about applied chemistry it involves using chemical knowledge to solve practical problems. So it has to do with using the knowledge you've acquired in chemistry, putting those knowledge together to solve a real-life problem. This real-life problem could be production of drugs, it could be production of cosmetics, agricultural products, or even maybe in other industry like food industry and the rest. So talking about applied chemistry, basically it has to do with the application of the knowledge of chemistry to solving problems. But when we are talking about pure chemistry basically deals with the acquiring the knowledge of chemistry, just more or less like the theoretical aspect of chemistry. Okay, so applied chemistry actually it bridges the gap between pure chemistry and industrial applications. So examples include developing new materials, pharmaceuticals, and energy solutions. Okay, so now quickly pause the video and take this quick assessment. How does applied chemistry differ from pure chemistry? Can you think of an everyday product that involves applied chemistry? Alright, you can quickly pause this video and pen down your response. If you are doing this as a group, try as much as possible to see if your response is kind of the same with other members of your group and come to a conclusion. You can deliberate, you can argue and come out to have a final conclusion. So this is my own opinion about the question, actually basically talking about the applied chemistry and the pure chemistry. so you can read through and also have a better understanding. So now, there is no how we'll be talking about applied chemistry that we won't be talking about chemical industries. So basically is this chemical industry that is like they are the body now that puts all these chemicals together by virtue of the chemists that they have. They cannot put these chemicals together and turn it to a product. So without the chemical industry, even if you have the knowledge of applied chemistry, your knowledge will not be able to be put into action that will actually bring about a product. Okay, so what are chemical industries? Chemical industry, basically they convert raw materials into valuable products. They include sectors like pharmaceuticals, petrochemicals, and agrochemicals. These industries are crucial for economic development and innovation. Okay, so we basically have many chemical industries. They could be the food industry. As you can see on your screen, this is trying to show the processes in food industry, and they could also be pharmaceutical industry that has to do with the production of drugs. Now, when we are looking at or talking about the pharmaceutical industries, now you will agree with me that in this case now they are producing drugs that has to do with that needs to be consumed to the body, and in such doing there is a very high need to produce a drug that won't be causing another problem to the body. So it is very important that when pharmaceutical industries they are trying to produce a drug, they must follow some processes. They must follow certain processes. First, the industry, if they want to produce a new drug, that drug must be targeted to something in the body. For instance, it could be that drug is going to be targeted at a particular enzyme in the body, maybe to inhibit that enzyme. When I mean inhibit, that is to temporarily stop the action of that enzyme, such that if the action of that enzyme is being stopped, a physiological process in the body will also be controlled. Okay, so now usually these drugs are usually targeted to something like maybe the enzymes in the body, or maybe hormones or some other biomolecules in the body. So for them to do this, that means that they will make use of raw materials. And actually they will also have to consider high level of purity when they are making their production. Now, basically, this industry, pharmaceutical industry, actually, they don't just produce the drug and say, okay, fine, these drugs are ready for consumption, and they dish it out to people for them to consume. Now, after the drug has been produced, it has to undergo trials. We call it clinical trials. And as a matter of fact, even before the clinical trials, it must have undergone the laboratory trials whereby it is being experimented. These drugs are used on animals. They seek the approval to use all these drugs for animals for experimental purpose, and see how the drugs affect the animal, and then they further go to clinical trials, using this drug on certain individuals that must have volunteered following particular protocols to do that. Then furthermore, the drugs are even still subjected to regulatory bodies that will finally accept if these drugs should be consumed by the populace or not. So basically, industry, they don't just come up and say, okay, they produce anything, even though it's food industry, even though if it's agricultural industry, pharmaceutical industry, they have to be sure that whatever they are producing is safe to the public and to the environment. But basically, every industry makes use of what we call raw materials for production. Now, these raw materials, it could either be chemical, it could either be fine chemicals or heavy chemicals, which we are still going to talk later in this lesson. Okay, let's take a look at this assessment quickly. Quickly pause the video and have this assessment done. Name 3 sectors within the chemical industry. Why are chemical industry important for the economy? So let's talk about raw material used in chemical industries. Basically, we say raw materials include natural resources like oil, minerals, agricultural products. Now, when we are talking about raw materials, we are trying to say those things used for production. Now, in most cases, the raw materials they are actually gotten from maybe natural resources. For instance, crude oil is raw material. Crude oil is raw material. Also, we could have other raw materials like maybe what do we call it now? For instance, some other oils too, they could also function as raw material. So when we are talking about raw material, they are the starter for any production. I would love that word, the starter for any production. Okay, so for instance, now we are talking about production of petrol, production of kerosene. The raw material there is actually the crude oil. It's from the crude oil that they could get petrol, kerosene, bitumen, and engine oil. So if a company or an industry want to go into production of maybe all these products like kerosene, the raw material they will also use, they'll be needing is the crude oil. Also, when we talk about plastic production, they also make use of part of the petrochemicals as raw materials for the production of plastic. So we are saying that this raw material, they are the starting point for manufacturing chemicals. I've said that before. Examples include crude oil for petrochemicals, minerals for metals. For instance, if we are talking about production of aluminium, aluminium is usually gotten from the raw material that we call bauxite. So bauxite is a raw material for production of aluminium. So for other metals too, like sodium, they have their raw materials. So, and we can also have plants serving as raw materials for pharmaceutical products, that is drug productions. Okay, now quickly look at these assessments on raw materials. These 3 raw materials used in chemical industries. How are raw materials transformed into chemical products? Okay, so you can just take a look at it once you are done. So raw materials are transformed into chemical products through a series of chemical processes and reaction. These steps typically involves extraction, manufacturing, purification, formulation, and quality control. I have said all this because of my explanation at the beginning of the video. Okay, so if you are watching this as a class, like as a group, you can quickly do this activity. So your teacher is going to provide you with some materials and you can use it to run the activity. So this activity is basically raw materials matchup. The objective of this activity is that you will quickly identify and match raw materials with the chemical products they help create. First, it will help to foster a rapid understanding of the connection between natural resources and the industrial output. So now what you're expected to do is that each group will be matching raw materials to the chemical products produced. Now, a card with inscription can be used for the different raw material. That is, maybe you can just have a card and then just write something like, okay, crude oil. Then you have different products that can be gotten from crude oil. So you are meant to now match those products that can be gotten from crude oil to the crude oil card. So you can also do more cards containing other raw materials like bauxite and so many other raw materials. Okay. Alright, so we are moving forward. So once you are done, remember to always pause the video and later continue once you are done with the activity. Okay, now let's talk about fine chemicals. So when we are talking about fine chemicals, these are materials used in various chemical industries. However, these materials, they are produced in small quantity then with high degree of purity. So when we are talking about fine chemicals, we say they are chemicals produced in small quantity and with high degree of purity. They are produced in small quantity and they have high value. Now, examples of examples of fine chemicals, they include the active pharmaceutical ingredient that is used to produce some drugs like penicillin, aspirin, and so on. So those active ingredients that is used in production of those drugs, they are actually classified under fine chemicals. Now, you agree with me that those chemicals, actually they must be very pure for them to use them, since they have to be consumed. Okay. Now, other examples of fine chemicals could be flavors, it could also be dye, and so on. Okay, quickly pause this video and do these assessments. What are fine chemicals? Give 2 examples of fine chemicals and their uses. So let's talk about heavy chemicals. So heavy chemicals, they are those chemicals that they are produced in large quantity and they have low degree of purity. They have low degree of purity. For instance, we could have ammonia. Ammonia is an heavy chemical and it can be used in the production of fertilizers. And we also have sulfuric acid that we call H2SO4. We could also have sodium hydroxide. Sodium hydroxide is also under heavy chemicals and they are used in production of soap. Okay. So quickly think about this assessment, pause the video quickly and attempt this. What distinguishes heavy chemicals from fine chemicals? Name 3 heavy chemicals and their industrial uses. Alright, so pause it and try to see how far you can attempt this. Okay, so let's quickly talk about the division of chemical industries. So basically we say chemical industries are divided into basic chemicals, specialty chemicals and consumer chemicals. So if we are saying basic chemicals, we are trying to say that the regular ones that at least is something, those chemicals that's virtually involving many chemical productions. But now when we are talking about specialty chemicals, those ones involved in the production of drugs now can be classified under this as well, because they could also be those ones used in research work. Basically, most of the drugs used in research work, they are specialty chemicals, because you might not be able to just find them or use them anyhow like that. But when we are talking about consumer chemicals, those could be those ones used in drugs as well as in food industries. Okay, so you can see what examples of the basic chemicals are, also that of the specialty chemicals, also consumer. Okay. Okay, quickly have this assessment, pause the video. What are the three main divisions of chemical industries? Provide an example of each division. So we have this final assessment here. The ammonia production facility, that's the title of the assessment. Now, a chemical plant produces ammonia through the Haber process, which is crucial for manufacture of fertilizers. Question: describe the chemical reactions involved in the Haber process and the conditions required for it. Imagine the plant faces a shortage of hydrogen gas. How would this affect ammonia production? And what alternative sources of hydrogen could the plant explore? The plant wants to increase its production rate. Discuss the possible changes to the reaction conditions and their potential effects on yield and cost. Okay, this is the final assessment, and this assessment is basically on production of ammonia by the Haber process. You might also want to consult the internet for further knowledge about this. However, know that in the Haber process, the basic raw material used is from gases, that is basically nitrogen and hydrogen that combines to form the ammonia, that is NH3. So you cannot think of how nitrogen combines with hydrogen to form ammonia, which is NH3, and the condition that might make this production cost effective and also brings about high yield. Okay, so that will be all for today's lesson. Thank you. So do remember to like this video and subscribe to my channel. Okay, see you some other time. Bye.